If we try to make again the formula for formic acid, it is CH2O2. And what about the structural formula? It's HCOOH. This is the formic acid. We said its name is, take care that the structural formula of the methanoic acid is a little bit peculiar, because you need to know that it is HCOOH. HCOOH. So don't start with the carbon saying COOH. Say HCOOH. The ethanoic. I have two carbons. So this carbon is what? Let's just remove this so I don't confuse you now. These two carbons, one of them is already in the carboxylic acid group, and this is my second one. Take care, don't draw two more besides the carboxylic group one. They are just total of two. Then our C double bond O and OH, as we learned how to draw the structural formula. CH3, carbon is attached to C2. This is the first carbon, the black one, and this is the green one, it's attached to OOH. Molecular, you don't know anything, just the numbers, C2H4O2, doesn't tell you anything. You won't even recognize that this is an acid from the molecular formula. What about the third one? We said, we forgot to say, this is commonly known as acetic acid. That's found in our vinegar. In vinegar at home, the normal vinegar we use with a salad, you put it, is just acetic acid. This is the name for ethanoic acid. The same way formic acid name is methanoic. Okay, so this one is C2. What about that one? This is a propanoic. Don't send together. Okay, so this is the propanoic 1, 2, 3. So C3H6O2, the black one around it 3 hydrogens, the red one around it 2. So CH3, CH2, COH. That's the structural formula for the propanoic. Take care, you count the carbon with the COH inside. Okay, this is a very common mistake from the students in the IGCSE exams to put another carbon in addition to the 3 carbons. Okay, the butanoic will be CH3, CH2, CH2, COH. So that's 1, 2, 3, 4. If you put the molecular formula, that's C4H8O2. This is the same acids that we talked about in the acids and bases and salts chapter, and we said they are weak acids. They are the weak electrolytes, which means what? They are partially ionized. Weak electrolytes, they produce hydrogen atoms, but in a very small concentration. That's why the pH of the solution is very good. Don't get confused. It's high, not low. It's high. So the number is ranging anything that's close to the 7. Yes, if this is neutral, so the strong acids is far away here, like HCl, HNO3, H2SO4, that's 1 to 2. But if you are 5 to 6, that's weak acids. Usually these are the, what we call the carboxylic acids or the organic acids. Methanoic, ethanoic, propanoic, they will still react as acids, but they are weak acids. What is the meaning of the word they will still react like acids? Do you remember all the reactions that we talked about in the acids? How they react with metals to form salt and? Okay, just a little bit stop here and to make sure that we know what we are saying. Excellent. So metals plus these carboxylic acids will still give you salt and hydrogen. And if it is plus the bases, means hydroxide, you mean, mister? Yes, plus base, you get salt and water. Excellent job. If it is plus the carbonates,
salt plus water plus CO2.
Very good. Salt plus water plus CO2. Okay, what about the salt? How do you do the salt for that? Can you tell me how to do? That's very easy. It looks difficult. It's actually a very easy job. What do you used to do to make the salt in HCl? You remove the H. This is an acid. It loses a proton. So you remove the H. You have a Cl minus. The salt is getting from the metal that's Na plus Cl, so you get NaCl. You will do exactly the same thing here. So that's CH3COOH. Remove the H. Remove the H again. So that will be CH3COO minus. Or if you want to write it with any metal, write CH3COO Na. CH3COO K. According to the metal you have used in the base, or if it's a metal alone. So what does it mean? If you react Na plus CH3COOH, the ethanoic acid, you will get CH3COO Na plus H2. H2, this is just a metal, right? So you need how many hydrogens here? This is 3 and 5. You need 2 hydrogens here. So what you would do to balance that one? So I have here H2 and here 3, so that's 5. How do you balance that one? To balance it, you need to make 2 from the hydrogens, because as we always said, this number is 2 and that one is 3. So the total is 5 and here 4. We always say if you have an odd number, you have to change it into an even number. You are not going to get an even number until the products are always even. So to do that, you have to multiply the odd by 2. So it will be 2CH3COO Na. Again, what is that? It will be 2 carbons, and here already there are, so this is 1, 2, so it is 4, and this, so we need to multiply this one again by 2. So it will be 1, 2 into 2 is 4. What about the hydrogens now? Let's see the hydrogens. Here, 3 multiplied by 2 is, and 2, total is 8. Now, 3 and 1 is 4, multiplied by 2 is 8. One thing is now not balanced. What is that? Oxygen is okay. Bravo, that's 2Na. So it's a balanced formula. This is very good exercise for the balance. This is how they react. How did we form the acids again? We formed the acids by reacting. Always remember this map for changing one compound into the other. It will help you a lot in the exam. If you want to get acids from the alcohols, what do you do for the alcohols? Use oxidation or combustion? Oxidation using oxidizing agent or oxygen? Oxidizing agent. There are 2 methods for the oxidation actually. One is a natural method using what? So one is a natural using what? I'll just add a file here to use it. Right. Again, we said there are 2 ways to form the ethanoic acid or the carboxylic acid from our alcohol. What is the alcohol that will produce it, by the way? Ethanol, very good. First, you do the oxidizing agent like something called potassium permanganate. How do you remember all these things? This is K, potassium. This is manganese. When you put O4, that's called manganate or permanganate or manganate 7. What is this headache? Just remember it. KMNO4. What is its name again? KMNO4. What is the charge of KMNO4? The whole thing is -1, and that's +1. They cancel each other. So what is the compound name? Potassium permanganate KMNO4. What is this 7? That's a very good question for the best students. This is the oxidation number of manganese. Since this year is the first year to put that, let's try to put that into work. KMNO4. Can you find the oxidation state of the Mn? Mr. Hisham will explain something no other Teacher explains. Let's remove the K. The total charge for MnO4 is equal to -1. Every one of oxygen is, multiply this by 4, you get -8. Manganese, -1, but this will be 8 minus 1. So Mn is, oh my God. Where did I see the 7? This is the oxidation state of the oxygen. Did you understand why it's called KMnO47? This is the oxidation state for the manganese.